Mastering SQL queries. Now that you've successfully installed SQL Server on your system and are ready to begin, it's time to dive into SQL queries. In this section, I'll explain what SQL queries are, the basic syntax, and how to design queries to interact with your database. We'll also go through the process of creating a table in a database using SQL statements. This is one of the core tasks in SQL, and understanding how to write queries is essential for working with databases. Let's get started. SQL queries, statements, and clauses. A SQL query is essentially a statement used to retrieve specific information from a database. It functions as a request, or a question posed to the database, asking for data that matches certain criteria. In this sense, it's quite similar to performing a search on Google and expecting a relevant, accurate result. SQL queries are the foundation of how we interact with databases to extract, update, and manage data efficiently. By writing queries, you communicate with the database to get the information you need. For example, using a SQL query, you can ask the database, "What's Joey's phone number?" And the database will respond with the correct information. To interact with databases and ask these kinds of questions, we use a standard and structured language called SQL. SQL is designed to help communicate with and manipulate databases. Writing SQL queries and statements is straightforward because much of it reads like simple English. SQL has a standard syntax, which allows you to structure commands effectively to retrieve, modify, or manage the data stored in database tables. Nuts and bolts of SQL statements. By now, you should have a good understanding of the scope and usage of SQL. In this section, I will introduce the different types of SQL statements that we will be using frequently. As mentioned earlier, in SQL, whenever we want to perform an operation, whether it's retrieving, updating, or managing data, we write SQL statements in the SQL Server and expect the desired outcome. The key is to ensure that the SQL statements follow the correct syntax. Example, let's say we have a table called table employee that stores employee data. Using SQL statements, you can perform various operations like retrieving employee details, updating their information, or even deleting records. Next, I'll guide you through writing some basic SQL statements to interact with this table. If you want to extract only the first name, last name, and email ID of employees from the table employee, you would write a SQL query to retrieve those specific columns. These types of SQL statements are known as SQL queries because they are used to query the database for specific information. To get the desired results, you would execute this SQL query. Select first name, last name, email ID from table employee. This query basically instructs the database to select only the first name, last name, and email ID columns from the table employee table and return the data for these fields. This SQL statement consists of the following key components that make it an effective SQL query. Keywords. In SQL, keywords are predefined and reserved words that play a crucial role in constructing SQL statements. These keywords have specific meanings and functions within SQL, and they are used to instruct the database on what actions to perform. In this SQL query, select keyword tells the database which columns you want to extract and display, and from keyword specifies the table from which the data should be retrieved. These keywords are essential building blocks in SQL queries, guiding the database on how to handle the request and return the desired results. Clauses. A SQL clause is a meaningful segment of a SQL statement that uses reserved SQL keywords to construct an effective query. Clauses help to define specific parts of the statement, guiding the database on what action to take and how to process the request. In this SQL query, two key clauses are involved. These two key clauses are select and from clause. Now you might be thinking that select and from are both keywords and clauses, right? But there is a difference between keywords and clauses. Let me explain. A keyword refers to a reserved word in SQL used to perform specific operations. Examples include select, from, where, etc. A clause is a part of a SQL statement that performs a specific function using one or more keywords. For example, select is a keyword. Select first name, last name, and email ID is a clause called the select clause. Similarly, from is a keyword, while from table employee is the from clause. A SQL statement is designed to perform specific operations in the database. These operations can range from extracting data to creating databases, tables, or even deleting deleting records. To manage data efficiently, SQL commands are divided into 5 main categories based on the type of operation they perform. These 5 categories of SQL commands are Data Definition Language, or DDL, Data Manipulation Language, or DML, Data Control Language, or DCL, Transaction Control Language, or TCL, Data Query Language, or DQL. Let me explain each category one by one. Data Definition Language. This category is used for defining and managing the structure of the database, such as creating or deleting tables and databases. DDL commands in SQL are create, alter, and drop. Create command. In SQL, the create command is used to create new database objects, such as tables, views, indexes, or databases. Here's an example of the create command. When this create command is executed, a table named employees will be created in the database with 2 columns, an ID column of type integer and a name column of type varchar 50. Alter command. This SQL command allows modification of an existing database structure, such as adding or altering columns. When this alter SQL command is executed, a new column age of type integer will be added to the employees table in the database. Existing records will have null as the default value for this column until updated. Drop command deletes database objects such as tables or databases. Here's an example of the drop command. When drop SQL command is executed, the employees table will be permanently deleted from the database, including all its data and structure. This action cannot be undone. Truncate command deletes all rows from a table. But unlike delete, it does not log individual row deletions. Here's an example of the truncate command. Data Manipulation Language. DML commands are used for modifying data within tables, including inserting, updating, or deleting records. DML commands in SQL are insert, update, and delete. Insert command. This command simply adds new rows of data into a table. Here's an example of the insert command. When this insert SQL command is executed, a new record will be added to the employees table, where the ID column will have the value 1, the name column will have the value John, and the age column will have the value 30. Update command. This command simply modifies existing data in a table. Here's the example of the update command. When this update command is executed, the age of the employee with ID 1 will be updated to 31 in the employees table in the database. Delete command. This command removes one or more records from a table. When this delete SQL command is executed, the record in the employees table where the ID column has the value 1 will be removed. Only that specific record will be deleted, and the rest of the table will remain unchanged. Data Query Language. DQL focuses on retrieving data from the database using queries. The select statement falls under this category. Basically, select command is used to query and retrieve data from a table. It can be combined with various clauses to filter and organize the results. Some examples of clauses that can be used with the select command include where, group by, and order by. Here's an example of a select command. When this select SQL command is executed, it will retrieve the first name and last name of all employees from the employees table, where the age is greater than 30. Only the matching records will be returned. The select command is the most commonly used in SQL and is fundamental to querying databases. It's worth dedicating extra attention to mastering its usage and variations. Data Control Language. In SQL, DCL commands control access to data in the database by granting or revoking permissions. DCL commands in SQL are grant and revoke. Grant command. The grant command is used to give specific privileges or permissions to a user. For example, you can grant a user the ability to view data without allowing them to modify it. Revoke command. The revoke command is used to remove previously granted privileges from a user. This ensures that users no longer have access to perform certain actions in the database. Introduction to privileges in SQL. In SQL, privileges refer to the rights or permissions granted to a user, allowing them to perform specific actions on database objects or within the database system itself. These privileges ensure that only authorized users can access or modify certain parts of the database. To better understand, think of privileges like roles in a restaurant. A customer doesn't have access to the kitchen, but they can sit and place an order. Similarly, database users are given certain privileges that define what actions they can perform. There are 2 types of privileges in SQL: system privileges and object privileges. System privileges. System privileges are broad permissions that allow users to create, modify, and manage the overall structure of the database. These are related to the administrative and structural management of the database itself. Here are some examples of system privileges. privileges. Create privilege. This privilege allows the user to create new database objects, such as tables, views, or indexes. Without the create privilege, the system will throw an error if the user attempts to create any object. Alter privilege grants the ability to modify or change the structure of existing database objects using the alter command. Drop privilege. This privilege permits the user to delete database objects completely using the drop command. This privilege is powerful and should be used cautiously, especially in live production environments. Those were the system privileges in SQL. Now let's move on to object privileges. Object privileges. Object privileges are more specific, controlling the actions a user can take on individual database objects like tables or views. These privileges typically focus on viewing or modifying data. Here are object privileges that can be granted to a user based on their role and responsibilities. Select privilege allows the user to retrieve or view data from a table. Insert privilege grants permission to insert new rows of data into a table. Update privilege allows the user to modify existing records in a table. Delete privilege gives the user the ability to remove rows of data from a table. Now let's move on to the final category of SQL commands, transaction control language. In live projects, users and applications frequently work with data, performing operations like extracting, loading, and modifying it. These activities generate many transactions in the database. A transaction is a group of database operations that are treated as a single unit. Transaction control language is crucial in managing these transactions within a database, ensuring data integrity and consistency. TCL commands help safeguard data during transactions by controlling how changes are applied or reverted. The primary TCL commands are commit, rollback, and save point. For instance, in a mobile banking application, customers perform transactions like transferring money, receiving funds, and updating their account details. Each of these actions manipulates data in the database, executing several DML commands. TCL is responsible for managing these operations, ensuring they are handled correctly and that data remains consistent. Okay, so let me explain each TCL command in detail to you. Commit. This command is used to save all the changes made in the transaction permanently. Once you commit a transaction, it becomes final and cannot be undone. Rollback. The rollback command undoes all changes made in the current transaction. It is used to revert the database to the state it was in before the transaction began, ensuring that partial or incorrect changes are not saved. Save point. A save point allows you to set a point within a transaction where you can later roll back to if needed. It gives you more control by enabling partial rollbacks within a larger transaction. Okay, great. Now it's time for some action. In this section, I will practically demonstrate how to implement these SQL commands to create databases and their objects, insert data, and view it. This section will cover all the different commands from the various SQL categories. This simple, hands-on practice will help solidify the concepts in your mind, creating simple databases and database objects with DDL. Now that you have a solid understanding of SQL commands and their categories, it's time to put that knowledge into practice. In this section, we will work together to create a simple database and its objects using SQL commands. When developing a database, it's crucial to have a clear conceptual understanding of the real-world system you're modeling. This begins with identifying entities, attributes, and relationships between those entities, which are typically captured in an entity relationship model, also known as ER model. If you want to learn how to create ER models, I have written a comprehensive article explaining the fundamentals of data modeling and how to create a simple ER model for an e-commerce system. Here's the link to the article. Once the ER model is ready, we can create the corresponding tables with the appropriate attributes and relationships. These relationships are transformed into a normalized relational model, and then SQL is used to create the database structure. Let's work with an example of an e-commerce model, which I've discussed in detail in the Mastering Data Modeling article. Steps to create a simple database. Step 1. Open SQL Server Management Studio. Step 2. Connect to your local server using Windows authentication. Step 3. Right-click on the server name and select New Query to open a query window. Step 4. Create the database. Create the database by executing the following SQL command. For this example, we'll create a database named myEcommerceDB. Here's the SQL statement to create the database. Step 5. Explore your newly created database. In the Object Explorer window, expand the Databases section. Look for My E-commerce DB to confirm that it has been successfully created. Pro tip: if you don't see the newly created database, click the refresh button in the Object Explorer and check again under the Databases section. Creating tables for entities in SQL Server. In this section, we'll create tables for the entities in our e-commerce model: products, sellers, customers, and orders. Each table will have its respective columns and data types, as we identified earlier. If you're familiar with data types, you should be able to follow along smoothly. Here's the SQL syntax for creating a table. Now execution time. Creating simple tables for the e-commerce model. Here's the step-by-step process. 1. Go to the e-commerce database. Open SQL Server Management Studio. In the Object Explorer, expand the Databases section and find the My E-commerce DB database you created earlier. 2. Open a new query. Right-click on the My E-commerce DB database. Select New Query from the drop-down menu to open a query window where you will execute your SQL commands. 3. Create the products table. Execute this SQL statement to create the products table. To execute, press the Execute or F5 button to run the command. This will create the products table with the specified columns, including product ID as the primary key. Now that you've successfully executed the SQL statement, you should be able to see the products table created under the My E-commerce DB database. Creating the sellers table. To create the sellers table, follow these steps. 1. Execute this SQL statement to create the sellers table. Creating the customers table. In order to create the customers table, follow these steps. Execute this SQL statement to create the customers table. With these steps, you now have both the sellers and customers tables created in your My E-commerce DB database. You can continue to create other tables or start inserting data into them. Creating the orders table. Execute this SQL statement to create the orders table. Inserting and viewing data. Inserting data into tables is done using the insert command in SQL, which falls under the data manipulation language category. The insert statement allows you to add new records to a table. Here's the syntax for insert command. Fetching records from a table. The select command is used to view or retrieve data from a table in SQL. It falls under the data query language category. You can select specific columns or all columns from a table using the select statement. Here's the syntax for the select statement, where column 1, column 2, column 3 are the specific columns you want to retrieve from the table, and table name is the name of the table, from where you want to fetch records. Here's the syntax to select all the columns present in a table. Let's dive into some practice exercises to deepen our understanding of these concepts. We'll start by inserting dummy data into each of the 4 tables in our simple e-commerce model, fetching a single record from a table. To select all columns for a specific record in a table, use this syntax. In this statement, where filters the results, so only records meeting the specified condition are returned. The system searches for records that match the condition provided after where. Here's one example to practice fetching single records from a table. In this example, the query will retrieve all columns from the seller's table, but only for the record where seller ID equals 44,444. Executing data insertion in the customer table. To add data to the customer's table, we use the insert command. Let's insert some data into the customers table with this command. When inserting data, ensure each value matches the correct data type for its respective column. Here's the SQL statement used to insert data into the customers table. Also, ensure that the number of values in your SQL statement exactly matches the number of columns specified. For example, if you specify all 7 columns for the customers table in your insert statement but provide only 4 values, the system will throw an error. Let me show it to you by entering lesser values in the insert statement. When the number of values doesn't match the specified columns, the system will throw an error. However, when the correct number of values is provided in the insert SQL statement, the data will be inserted smoothly. Now, let's view the data we inserted into the customers table using the select statement. To retrieve all the data from the customers table, use this SQL query. To retrieve data for specific columns, like customer ID, first name, last name, contact, and email from the customers table, use this query. Similarly, we can insert and retrieve data using SQL statements for the rest of the tables. Inserting data in the orders table. In this section, we'll insert 2 rows into the orders table simultaneously using consecutive insert statements. The system identifies the end of each SQL statement by the semicolon. Here are the SQL statements used to insert data. Simply execute these statements one after the other in the query editor. The system will process each insert command and add the respective rows to the orders table. Next, let's retrieve all the data we inserted into the orders table. Use the select statement. This query will display all columns and rows in the orders table, inserting data in the products table. To insert data into the products table, use these insert statements. Execute these statements one after the other to insert the data into the products table. In the third record, you'll notice that a null value has been inserted for order ID. This is because there hasn't been an order placed for this product yet, so no value is assigned to order ID. After executing these insert statements in the My E-commerce DB database, you can display all the data in the products table with this query. This query will retrieve and display all records in the products table, including the null value in the order ID column for products without orders. Inserting data in the sellers table. To insert data into the sellers table, use these insert statements. After executing these insert statements, you can display all data in the sellers table by running the select query. These examples demonstrate the simplest way to insert data into tables and retrieve columns from these tables. Updating data in a table with SQL statements. By now, you should be comfortable with inserting records into a table and retrieving data from it. However, in real-life scenarios, databases frequently need updates due to events like price changes, product sales, and more. To handle such updates, we use the update SQL statement. Here's the syntax for update statement. Where table name is the name of the table where the data needs to be updated. Set specifies the columns to be updated along with their new values, and the where condition filters the records to be updated based on the specified condition. The update statement will modify only those records that meet the conditions specified in the where clause. Updating data in table. In our e-commerce model, let's say the customer Chandler has moved to a new apartment in the same city and updated their address on the e-commerce website to ensure future orders are delivered to the correct location. The new address is 111. Maspeth Avenue, New York. Updating this existing record requires an update SQL statement. Here's the SQL statement that will update the record in the customers table. This query will update the address only for the record where customer ID equals to 112. Since customer ID is a unique primary key, only one record's address will be updated. Execute the update query and then retrieve the results. As you can see, the customer address column is now updated. This demonstrates how records are modified using update SQL statements, which is why it falls under the data manipulation language category in SQL. Deleting data from tables. Using SQL statements. In databases, incorrect or unnecessary records sometimes need to be removed. For example, in our e-commerce model, suppose the seller Home Care LLC launches a new product, Smoothie Blender, on the website. After a few months without any sales, they decide to remove it from the site and the database. In this case, the following database operations would occur. A. Insert a new record for the product in the products table. B. Delete the product record if it is no longer needed. Let me explain each of these steps to you in detail. Step 1. Inserting a new record. First, we insert the new product into the products table by using the insert command. In this statement, order ID is set to null because no orders have been placed for this product yet. Step 2. Deleting the record. Next, to delete the record for this product, use the delete statement. This delete statement removes the product record with product ID equals 4,444 from the products table. This is how we use various DDL, DML, and DQL statements to perform multiple operations within a database. That's all for today. See you in the next one.